Hey, welcome to the Explainer. Our planet is constantly sending us signals. In the weather, the oceans, the ice caps, it's talking to us. And today, we're going to explore how a really powerful form of AI is finally helping us figure out what it's saying. Okay, so picture this. Every single day, our planet generates terabytes of data. I mean, from satellites way up in orbit to sensors buried deep in the ocean, it's just this constant flood of information. It's almost like the Earth is trying to tell us something, but its voice is just lost in this massive storm of raw data. So the big question is, how do we even begin to listen? And that really gets to the heart of the problem, right? We have all this data. We are literally drowning in it. But data isn't the same as actual knowledge, is it? We're swimming in numbers, but we're desperate for real, actionable insights. And that's exactly why we need a whole new kind of tool to breach that gap. All right, so to find that tool, we've got to understand the basics of how machines learn. And really, it kind of boils down to two main ways. First up, you've got what's called supervised learning. Think of it like teaching a kid with flashcards. You show the AI a satellite picture and you tell it, hey, that's a forest, that's a city, and that right there is water. You're giving it the answers. Then, on the flip side, you have unsupervised learning. This is totally different. You just dump a massive unlabeled pile of data on the machine, like, say, a bunch of ocean floor scans, and you just tell it, go find the patterns, group the similar stuff together. You don't give it any clues. Now, deep learning, that's where things get really interesting. It takes this whole idea a giant leap forward. It uses these really complex systems called neural networks, which are, you guessed it, inspired by our own brains. Just like our brain processes information in layers, these networks push data through level after level, which lets them spot incredibly subtle and complex patterns that we would totally miss. Okay, so our first power tool has a bit of a tricky name: convolutional neural networks, or CNNs for short. The easiest way to think about these guys, they're like AI's feature detectives. They're absolute masters at looking at images and spatial data, like a satellite photo, and just breaking it down piece by piece to understand what's there. So you might be wondering, how does a CNN actually see something? Well, it doesn't see a picture of a coastline the same way you and I do. What happens is the first layers of the network apply these digital filters to find really simple stuff, like basic edges or patches of color. Then the next layers combine those simple things into more complex shapes. Maybe it starts to see the outline of a glacier. And then finally, after all those layers, the network makes a call and classifies what it's looking at. And this process, it has a huge real-world impact. This isn't just theory. Scientists right now are using CNNs for incredibly important jobs, like automatically spotting landslides before they happen, mapping glaciers that are covered in rock and debris, and even identifying extreme weather patterns right from the satellite data. It's a game changer. Okay, so if CNNs are the AI's eyes, then our next power tool, recurrent neural networks, or RNNs, is basically its memory. What makes them so special is their design. They have these things called feedback loops, which lets them remember what came before. So they don't just see a single static picture, they can understand a sequence, a whole story as it unfolds over time. So, a memory for an AI, where is that useful? Well, it's absolutely perfect for tracking the planet's pulse, for watching how things change. We're talking about forecasting groundwater levels in coastal cities that are prone to flooding, or predicting how sea ice is going to shrink and grow as the seasons change. It can even simulate how an entire ecosystem remembers a past event, like a major drought, and how that affects it years later. All right, so we've got the tools. We have the eyes and the memory. Now let's see what happens when we put them to work decoding our world. First on the list, climate models. You see, the traditional models we've used for years, they often have a tough time with the really small-scale stuff, like how individual clouds form. Scientists call these subgrid processes. But deep learning, it can learn these super complex patterns directly from high-res data. And what that means for us is that both our long-term climate predictions and our short-term weather forecasts get a whole lot more accurate. Okay, next, let's zoom out and look down from space. An AI can comb through satellite images with a speed and a level of detail that, honestly, no human ever could. And we're not just talking about spotting a car or a building. This is about classifying every single pixel in an image. It's a technique called semantic segmentation. That lets us precisely map everything, from urban sprawl and lake ice to those tricky, hidden glaciers covered in rock, and even areas that are at high risk for landslides. And this incredible power doesn't stop at the surface. It goes deeper. Deep learning is becoming absolutely crucial for managing our most vital resources. We already mentioned how it can forecast groundwater levels, right? But it can also be used to sniff out anomalies in methane concentrations just from environmental data. It can even help us assess the composition of soil, which, as you can imagine, is critical for everything from farming to environmental science. Okay, so that all sounds great, but how much of a difference does this stuff actually make? Well, let's take a concrete example, mapping glaciers. If you look at this chart, you can see that the traditional methods, they're okay, but they really struggle when ice is covered in rocks and debris. But look at the deep learning results. The accuracy is significantly higher. That means we get a much clearer and more honest picture of how our planet is changing. So what's coming next on the horizon? The next big wave is something called foundation models. The best way to think about these is imagine a massive AI model that's already gone and gotten its PhD in earth science. It's been pre-trained on just a staggering amount of data. Then, scientists can take this expert model and quickly tweak it, or fine-tune it, to solve a whole bunch of very specific problems with just incredible speed and efficiency. You know, we are really just scratching the surface here. Which brings me to one final and kind of mind-bending question. What new secrets is our planet going to reveal to us when we combine these incredibly powerful AI models with the next giant leap in computing, quantum computing? The possibilities, they're just staggering to even think about.